Hi, welcome to Core Java tutorial, and today we are going to cover the topics called what is an object-oriented programming language and what are the concepts of OOPs and why do we need an object. Okay, so let us discuss the first, what is an object-oriented programming language. Okay, so any programming language can be called as an object-oriented programming language if it satisfies all the features of an object-oriented programming language, right? So it's a simple definition. So what is an object-oriented programming language? An object-oriented programming language is the one which satisfies all the features of object-oriented programming language. Then what are the features of object-oriented programming language? The features of object-oriented programming language are: the first one, polymorphism, and encapsulation, and the third one is inheritance. Okay, or encapsulation, polymorphism, and inheritance. So these three are the features of object-oriented programming language. Okay, so you might heard somebody saying that there are 8 or 9 features of object-oriented programming language, including class, object, and polymorphism, encapsulation, inheritance, and message passing, message binding, something, right? So I can say these three concepts are only the features of object-oriented programming language. Then what about the remaining? So what are the remaining? Object, classes, and message passing, okay, and something most of the people use it to say that including this one also, inheritance, right? So what are all these? What are the remaining things, right? So these I can say that these three only the features of object-oriented programming language, and the remaining all are the implementations of these three concepts. So that is the reason most of the people are used to say all together as an object-oriented programming, I mean the features of object-oriented programming language. Okay, so in practice the people will say all together as the features of object-oriented programming language, but only the three features, so encapsulation, polymorphism, and inheritance. So these three features can be called as the features of object-oriented programming language. Okay, so these are all the OOPs concepts, right? So these are all the OOPs concepts. Okay, fine. So in the previous tutorial we have discussed, or we have explained one main program. So let us take a class. So class, I will name it as A, and inside this I will take one variable, static int I. Okay, then I will take one main function, public static void main, okay, string box. Okay, so here inside this I will write one system dot out dot print ln. So here I will print I over here. Okay, now save this program sorry, with the name Core Java. So inside this I will save this class with the name a.java. Okay, save this and you go to that folder, okay, and open the command prompt here, and you just compile this Java class, Java C space a dot Java. So there is no compilation error, and I will run this class. So we are able to see the value of I is 0 here, right? Let us divide this, right? Okay, so now I will remove this particular static. Okay, I am saving this program and I am just simply compiling the program over here, and you can see the error here, right? The error is saying that non-static variable I cannot be referenced from the static context, right? That means the whatever the variable which we have defined as a non-static over here in this class, this will not be accessible to the static functions. So then what will happen in the background when we run this or when we compile the program, right? So when we compile the program, so what will happen is the Java compiler checks whether the accessibility of this particular defined variable is available in this particular function or not, because we are using this particular variable here. So since the variable which is a non-static, right? So non-static variables can also be called as an instance variables, right? So I will explain you why do we call these non-static variables as an instance variables. Okay, so here, because this non-static variable cannot be accessed in the static context, so that is the reason it is throwing an error. So if you want to avoid this compilation error, so we need to define it as static and save this program and compile the program over here, and you won't get any compilation error here, right? So I don't want this variable to be declared as a static. I want this variable to be as a non-static variable. Then how can I access this particular variable? So if I compile this particular program, so now it will throw a compilation error saying that the non-static variable cannot be accessed in the static context. Okay, so I want this variable I to be act as a non-static variable, and I want this variable to be accessed here. Then how can I access, right? So let us create an object of this class A. So how can you create an object? So class name and the reference variable name equals to new A. Okay, so this is how you want, you have, this is the syntax which you need to follow while creating an object. Okay, so A is nothing but the name of a class, and here this A is a name of a variable into which you want to save the object of this particular class. So here see new A, so we can create an object of a class using new operator. Okay, so new A, in the sense it will create an object for the class A, and this is the object of type A, so that we are going to save this object in the same type. Let us say here I am going to create one integer variable, int I equals to 10. What does it mean? So a 10 is a value of type integer. That is the reason we are saving this value 10 into the variable called I of type int, right? So in the same way, this is also one value of type A, so that is the reason we are going to save this value inside a variable called A of type A. Got it? And save this program, and you access, see, once you create an object of this class, you can access this particular variable through this particular object. So since we have created an object over here, the object has been saved in this particular variable. So now you can use this variable A dot. Okay, so you can use A dot. That means whenever this particular statement will get execute, it will check what is A first. So here A is an object of type A, right? So let us open this. So here what will happen is it will create one object like this, then it will load all non-static variables into this particular object. Okay, so what are all the non-static variables available here? So the non-static variables available are only int I, right? So what will happen when we create an object first, right? So whenever you create an object, first the JVM will allocate some space in the RAM, and it will load all non-static variables into this particular allocated memory space. Then this object, the address of this object will be saved into the reference called A. Okay, into the reference called A, right? So this is what happens when we run the program. Okay, so here in this scenario what will happen is this particular variable I will be loaded to the RAM, and I mean to say, whenever you create an object, what will happen? So the JVM will allocate some memory in the RAM, and it will load all non-static members, not only variables. If any functions are there, so that will also will get load to the RAM, and then finally the address of the object will be saved into the reference called A. Okay, so I can say index of address of object will be saved here, not exactly an address. The index of address of this particular object will be saved into this particular reference. And then if you want to access this variable, then obviously you have to use A followed by the dot operator, and then with what is the member you want to access, right? So now you save this program. So see here, I took one non-static variable. If we want to access the non-static variable into the static context, then obviously we have to create an object. That means what? So here this compiler is saying that hello boss, so you have created one non-static variable over there in the class called A, and you are trying to access this particular variable inside the main function, which is a static one, right? So this, I don't know what this variable is at the runtime, so you need to make this variable available to this main function at runtime, right? So if I define this particular variable as static, and if I comment this line, and now let us see, I will remove this. Okay, so here compile this program and run the program. That means at the compilation time itself, the JVM or the Java compiler is checking that whether this can be accessible here inside this main function or not. Yes, it is accessible. So now what happens when this particular main method runs? So whenever you try to run the program, so what will happen is whenever you after the compilation, whenever you try to run the program, the JVM will load the the main function from the class file to the RAM first, then it will execute the main function. Okay, so since this particular variable is accessible at that, that means what, here we are accessing this one in the sense we are able to load these particular static variables to the RAM. So that is the reason we are accessing over here. So here if we define this one as non-static, and if you compile this, and here the Java compiler, see here the Java compiler is saying that so this cannot be accessible at the runtime. That means we need to make this available at the runtime in the sense what, at the time of running the program. So if you want to run the program, obviously we will have to load all these members together to the RAM first. That means here this error is saying that at the time of running the program, this will not be available in the RAM, right? So it is giving an error in the sense this variable cannot be, it is not able to load to the RAM. So we need to load this particular variable to the RAM first, then we need to allow the program to access this variable. Okay, so how can we load this particular, see if I create an object over here, okay, if I create an object over here in the first line, then obviously what will happen, we are loading, see we are loading this particular variable to the RAM, and we are making this all non-static variables available to the main function, right? Okay, fine. So if we load, see once we load this particular variable to the RAM, that will be available with the reference, in the object called A, and which is stored in the reference A. So this is an object of class, see this is an object of class A, and this particular total object has been saved into the reference or the variable of type A. Okay, so now see because of creating the object, all non-static variables, okay, all non-static variables will be available to the main functions. Okay, how these non-static variables will be available to the main function? Through the reference of that particular object. Okay, now you compile this program. So you compile the program and run this program. See now it is giving us an output I equal to 0. Okay, now I will remove this a.i. Okay, now you compile this program. Again it is saying that non-static variable I is cannot be referenced from the static context, right? Though we load this particular variable to the RAM, so it is available in the RAM, so in this particular object. So if you want to access that particular variable, then obviously you have to use this object. Okay, you have to use this object, right? So now you just compile the program and run the program. See, there is no compilation error and it got executed fine. Okay, now there are some more points which you have to keep in mind in this program. Okay, here what is, so you might heard something called instance of a class and object of a class, right? So I told you that these non-static variables can also be called as instance variables, right? Non-static variables can also be called as instance variable. So what is the reason behind this, that we are calling non-static variables as an instance variables, right? What is an instance? Okay, an instance. So first, what is an instance? An instance is nothing but the dynamic memory allocation, okay, or any dynamic memory allocation can be called as an instance, right? So here what is happening at the time of creating an object over here? See, it is getting load to the RAM in the sense, first what will happen, the JVM will allocate some memory space in the RAM first, then it will load all non-static members to the RAM, right, into the allocated memory space. That means what, this is happening at the, this is happening when we run the program dynamically, right? So this is happening dynamically at the time of running this program. right? So what is an instance? Any dynamic memory allocation. See, because of creating an object of this particular class, we are allocating the memory space in the RAM dynamically at runtime, and we are loading all these non-static variables to the RAM or allocated memory space at runtime dynamically, right? So nothing but we are creating an instance over here, right? So here, what is an instance? Any dynamic memory allocation can be called as an instance. If you come here, that is what we are doing over here, is it? So here we are creating an object, in the sense what we are dynamically allocating some memory space in the RAM first, then we are loading all these non-static variables together into that particular allocated memory space dynamically at runtime. So here, since we are allocating the memory space for something, for this particular non-static variables dynamically at runtime, this can also be called as an instance. We are creating an instance of a class A here. That means, yes, we are instantiating the class A. So instantiating the class A and creating an instance of class A, both are equal. Okay, fine. Then what is an object? Okay, I told you before that this is an object, right? So an object is nothing but it is also a dynamic memory allocation. It is also dynamic memory allocation. Okay. Yes. An object is also a dynamic memory allocation. Fine. Then what is the difference between an object and an instance? Right? So see, what can also be, see, this is also an dynamic memory allocation. This is also a dynamic memory allocation. Then which dynamic memory allocation can be called as an object? Right? If you consider if the dynamic memory allocation happens only for the classes, okay, if the dynamic memory allocation happens only for the classes, then that particular dynamic memory allocation can be called as an object of a class. If dynamic memory allocation can be happened only to the classes, then that particular memory allocation can be called as an object. Okay, if the dynamic memory allocation happens, if the dynamic memory allocation happens only to the classes, then that particular dynamic memory instance can be called as an object. So apart from the class, whichever the thing, for that, if the dynamic memory allocation happens, that cannot be called as an object, right? So if you consider the C language, if you consider C language, in the C there are some functions available, some calloc and malloc functions, MALC something, some calloc and malloc functions are available, right? So using which we can allocate the memory dynamically for the structures in C language. So in C language, have you ever heard about the objects? No. But if you come to the point of C++, there is a concept called object, because in this particular C++ language there is something called as class. So in C language, though we are allocating the memory dynamically at runtime for the structures using calloc and malloc functions, so those memory allocations cannot be called as an object, since the structures are not the classes. But in C++ there is a concept called object, because there is a concept called class. For the class, we are dynamically allocating the memory, and that is the reason we call the dynamic memory allocation can be called as an object. Okay, so that is the difference between instance of a class and object of a class. And one more thing, you might heard that all the instances are not objects, but every object is an instance, right? So you might heard this particular statement, right? That means all instances are not objects. That means instance is what? Dynamic memory allocation. Dynamic memory allocation can also be done in C language for the structures. That means here whatever the dynamic memory, whatever the instance which is happened over here, that cannot be called as an object. But if you come to the point of this Java, okay, if you come to the point of this Java, here also we are allocating the memory space in the RAM dynamically at runtime, nothing but instantiation or instance, right? So that can also be called as an object. So but every object is an instance. Here object in the sense what? Again it is a dynamic memory allocation, but this is happening only for the classes, so this can also be called as an instance. You got my point? So in C language, though we are allocating the memory space for the structures, we are not calling that one as an object, since that is not a class. So in Java we are allocating the same dynamic memory, the same concept in dynamic memory allocation, but that is happening for the classes. That is the reason we call this particular dynamic memory allocation as an object. Okay, so here you understood this particular statement. So all the instances are not object, but every object is an instance. Got my point? See, for this I can say that all literates are not job holders, but every job holder is a literate. Got my point? So you understood this statement. So all literates are not job holders, but every job holder is a literate. That means the person who is doing some job, in the sense obviously he must be a literate, and there are so many literates who are not having the jobs. Got my point? So that is the reason, I mean to say, so this is the reason why they had mentioned this particular statement. All instances are not object, but every object is an instance. Okay, fine. Here in this particular program I have already explained you that these non-static variables can also be called as an instance variables. Why do we call these non-static variables as an instance variables here? So how this particular variable will get load to the RAM? This particular non-static members will get load to the RAM because of the object, right? So what is happening when we create the object? So when we create the object, the JVM will allocate the memory space in the RAM dynamically and load all these non-static variables to the RAM, right? So we are creating an object, in the sense we are instantiating this particular class. We are creating an instance of this particular class. So since these variables or these non-static members will get load to the RAM, because of the instantiation, right? So because of the instantiating the class, we are loading all these non-static variables to the RAM. That is the reason we call all these non-static variables as an instance variables, right? Okay, so because of the instance, all these variables are getting loaded to the RAM. So that is the reason we call these non-static variables as an instance variables. Okay, and here if I create a static variable, static int j equals to 10 or 20, so I will create this, I will print this particular variable here in this main function. Okay, so here j equals to, so you can, since this is a non-static variable, this is a static variable, we can directly access the j over here. Since j is a static variable, we can directly access this particular static variables in the static functions. So here I can directly access this. Okay, now you just compile the program and run the program. See, j equals to 20. Now what I will do is a dot j. Okay, save this program and compile this program. See, there is no compilation error, and run the program. See, what makes the difference over here then? Okay, so here I am able to access this particular int with the reference a, and I can also access this particular j with the reference a. Though if I don't use this particular reference over here, this variable is getting access over here. Then what is happening in the background? See, there is no compilation error and it is executing fine over here, right? So there is something called static. Whenever we discuss about this variable static, I will explain you what will happen in the background. So as of now, you just keep in mind that, so these particular static variables can be accessed directly in the static functions. Okay, and these static variables can also be called as class variables. Okay, these static variables can also be called as class variables. Okay, so today in this class we have discussed about what is an object, and one more thing, why do we need object, right? And why do we need objects, right? So here I have created an object and I'm just accessing these non-static variables with the help of the object over here, right? So then what is the use of this particular what is the use or what is the need of this particular object? What is the use of or what is the need of instantiating the class, right? So we need object only to load the non-static variables to the RAM. That's it. Okay, we need object only to load non-static variables to the RAM. Apart from this particular purpose, we do not need this particular object. Okay, so in order to load the non-static variables to the RAM, so we need an object. So until and unless we won't create the object of the particular class, then until and unless you won't create an object of the class, object of this class, the non-static variables or instance variables of this instance variables or instance members of the class will not get loaded to the RAM. If you create an object of a class, then only the instance variables of this particular class will get loaded to the RAM. Okay, so in order to load the non-static members or instance members of a class to the RAM, we need an object. Apart from that, object is not required for something else. Okay, so is it clear? Yes. So today in this class we have covered what is an object-oriented programming language and what are all the features of object-oriented programming language. Then why do we need an object, and what is an instance, and what is an object, and why do we call, what is the reason behind this particular statement saying that all instances are not objects but every object is an instance. Okay, And today in this class we have covered all this, and let's discuss furthermore in the next classes. Thank you for watching.